Joining us here on Real Agriculture again, we have Brunel Sabourin of Antara Agronomy, and Brunel standing in a mosquito-infested field that we just flew a drone over. A lot of farmers, Brunel, and agronomists have picked up drones in the last year or two with RGB cameras, possibly NDVI cameras on sensors on them. How do we now use these maps and turn them into something that we can actually act upon in terms of managing our crop?
For sure. Hi. Yeah, as mentioned, a lot of farmers have drones these days, just entry-level drones. There's a lot that they can be used for. RGB imagery is just basically a true color image. So fields can look quite different when you're looking at them from 200 or 300 feet above. We're looking for patterns in the fields and different management areas that maybe we can improve our management of.
So you have some tools that you're wearing and that you're holding there.
Yeah.
Why don't you take us through some of the other things that we can use to kind of complete the picture or complement the data that we acquire from a drone?
Yeah, there's a lot of different apps available that you can use your drone to actually map out a field. When you're mapping out a field, it gives you a true square image from above that you can use then to quantify acres. So it becomes a tool that can help you in your management decisions. Now, what's important though is to say, okay, we know this area is different from that area, and we know there's 30 acres, let's say, but what is the reasons that it's different? So then it's important to use this imagery now, get in the fields, and this is a perfect time of year while there's still crop out to see what's going on in those fields. Are they depressional areas that are drowned out? Is it a soil texture issue where there are things that range from clay to sandy soils in a field? Or is there other underlying factor? So to do that, we've got different tools like a green seeker, which measures NDVI, chlorophyll meter, which gives us a little bit more accurate reading on the chlorophyll in the plants, but even just the trusty old soil probe to see what kind of soil texture we're dealing with, or to take soil samples in these different areas that we can compare one against the other.
This way you can use that map to break the field into those different parts rather than just kind of going with random sampling.
Well, it's trying to better understand what's happening in your fields, breaking the management of the field. Instead of farming by the quarter or by the half, we're breaking it down into 4 or 5 management zones. It's another layer of information that we can add to satellite imagery, to topography maps, to just the general knowledge of the field. How can we better manage these different areas of the field?
So we just came from a cornfield where you had some plans for how you're going to use the imagery coming from that field. Can you use that as an example then? Kind of explain one application for it?
For sure. We're going to take the imagery from the field. Once we've flown the field with the regular RGB camera, we have satellite imagery, so we have a bit of historical records, but the NDVI image in the field is going to allow us to go into the field because we'll be able to see exactly where we are in the field on a tablet or on any kind of smartphone. So we can go right to those specific areas and start looking and comparing the good versus the bad.
And do stock nitrate tests and things like that?
Yeah,
well?
In that particular field, we're going to do stock nitrate test. That's a good measure of how much nitrogen uptake there was in the corn to figure out if there's areas that were deficient or areas that had luxury nitrogen uptake. We're going to compare that to the yield map. We're also going to look at those same zones and go in there and look at the soil texture. We're going to take soil samples, send them away to the lab. So we'll probably end up with 5 or 6 different layers of information on that field to try to figure out what exactly, is there a way that we can manage that field differently that'll either, make better use or more efficient use of our inputs or maximize the yield? Are there some areas where we can actually improve the yield?
Mm-hmm. Would you say that this technology, some of it that you're holding there, the drone, that we're still in the early stages of kind of the verification and understanding how things correlate in the field, the ground truthing, I guess, that's what we're talking about here essentially. We're still trying to understand that.
Yeah, it's important to understand what the reasons are in the field to see what you see. It's fine to have a map at the end of the year and say, this area was good, but this area was bad. We can have a poor area of field on a ridge that it's because it doesn't have enough water, but in the same field there'll be a similar yielding area, but it's a low spot that's had excess moisture. So on the map they look the same, but it's not necessarily a true representation of what's happening in the field.
Mm-hmm. And we've seen so much tech come to agronomy in the last 5-10 years, and it's showing no signs of slowing down. I think there's still some work being done in terms of understanding exactly what the numbers mean.
Yeah, I mean, everybody's aware of the big data, collecting all of the data and trying to make sense of it. But before we have big data, we have to start with little data, which is there's so many different variables that affect yield, weather being one of the major ones, that we need to have a better understanding of what's happening locally before we can start comparing ourselves over a wider geography. Make sure we're comparing apples to apples as best we can.
All right. Well, we'll let you escape. We'll head out to this mosquito-infested area, maybe back to the road here, Brunel. Thanks for your time.
Okay, thank you.